Assalamualaikum warahmatullahi wabarakatuh and good day, Doctor. My name is Nurul Farhana binti ZAINAL RASHID, MATRIC ID B22EC0053, and this is my presentation video for Project SARJANA MUDA 2. The title of my project is HATELIER, Interactive Real-Time 3D Drawing Guide Using Hand Gestures in WEBAR. My supervisor is Dr. Fazliati Idora Betty Fazli. So these are the contents for my presentation today. Introduction, literature review, methodology, implementation, evaluation and results, and finally the project conclusion. First, introduction. So the problem background for this project focuses on two different aspects, which are constraints in traditional drawing method and also limitation in digital drawing method. So for the traditional drawing method, we often need to have the ample time and space to draw, and we also need to have physical medium such as the canvas, the paper, paintbrush, pencils, color pencils, and so on. For digital drawing method, such as digital drawing tools such as tablet or styluses are often expensive and may not be accessible to students or casual users. And despite there are a lot of digital drawing softwares nowadays, many of them are platform specific and require installation, leading to platform lock-in and limited cross-device compatibility. Meaning that, for example, if I draw in Medibank Paint Pro, and I save the file and then I want to use the file in the other drawing software such as Procreate, I can do that because the save file is only specific for the platform, and I may able to export it in different file format, but it still the limitation is still there. Next, project aim. The aim of this project is to develop an interactive real-time AR drawing guide using AR 3 drawing guide using hand gestures in WebAR. These are the project objectives. First, to study and explore hand gesture interaction and markerless tracking for AR. Second, to design and develop a 3D drawing guide web-based AR application with hand gesture interaction. Lastly, to evaluate the AR 3D drawing guide web-based application as interactive media that could increase users' drawing experience using AR. These are the project scopes. The application is a single user 3D drawing guide web-based AR application built to increase users' experience in drawing using AR. The application uses location-based AR. The application integrates hand gesture interaction. The application is a web-based AR application. In the start screen, the application allows the user to choose whether they want to enter the draw mode or the tutorial mode. In draw mode, user is able to draw freely using hand gesture interaction. User can change the brush size and colors, undo and clear the drawing. In the tutorial mode, there will be three different levels. So user need to choose which level they want to use, either easy, medium, or hard. And in each level, there are three different shapes. In easy level, there are circle, triangle, and square. In medium level, there are flower, bunny, and a sun. And in the hard level, there are a house, a tree, and a fish. So only one model can be chosen at a time. Once the user already choose a model, a low opacity model will show up in the user screen, and user need to draw over it. Once the drawing is completed, there will be an animation showing the model is now completed, and user can return to the main menu to choose other guides. So the application uses the user device camera to detect hand gestures. Literature review. Augmented reality. So AR is considered as enhanced direct or indirect real-time view of a physical real world environment due to virtual computer-generated information being attached to it. AR is interactive in real time, registered in 3D, and combines real and virtual images together. So there are different applications of AR nowadays, including in logistic area, architecture, education, healthcare, and also online shopping. There are two main types of superimposition AR. First is the marker-based, and second is the markerless AR. In this project, I use the location-based under the markerless AR. So the web-based AR. Web-based AR enables smartphone user to engage in AR technology in a serious way through web page without needing any installation. And most of the devices with Android 6 and above supports web AR. So there are many technologies can be used to implement the AR in web, but the one that I chose for this project is ARJS. ARJS is a purely web-based framework written entirely in JavaScript. It supports location-based and also marker-based AR. So for the marker-based AR, It takes the device GPS and compass data to position virtual content in the real-world coordinates. Next, hand gesture interaction. Hand gesture interaction falls under natural user interaction, NUI. NUI allow users to interact closely similar to real-life actions that enable them to learn, understand, and adapt quickly with little mental load and training needed. So the figure shows the example of hand landmark model taken from the Google Media Pipe. And then there are different technologies to integrate hand gesture, for example, OpenCV, MediaPipe, TensorFlow, and so on. The MediaPipe is chosen for this project because its capabilities and compatibility with browser-based environment. So for MediaPipe, the gesture recognition through the hand is detected through the connector and landmarks. So the distance between connector will be calculated to determine what gestures the user is currently doing. Next, 3D drawing. 3D drawing is the process of creating visual element that occupy spatial dimension, which is the width, height, and depth within a virtual environment. So there are many types of techniques for 3D drawing. The technique that I follow is the freehand on the left side, outlined by the Dudley in their paper, and the freehand technique, meaning that you draw like a similar real life drawing type technique. So 3D drawing guide is a visual aid used to assist user in drawing shapes or objects within 3D space. So the figure shows an example of 3D drawing guide made by the University of Cambridge. So these are the previous works that has similar technologies with this project. First is Paint AR, second is Sketch AR, and finally the bare-handed 3D drawing in augmented reality. So these are the comparison between the previous works. As we can see here, Paint AR enable user to draw in AR space, and it also has hand gesture interaction. However, it doesn't have 3D drawing guide, and it only available on mobile. And Sketch AR, made by Sketch AR UAV, it doesn't support drawing in AR, but it has hand gesture interaction and also has 3D drawing guide. So meaning that for the Sketch AR, user can only see the overlay of the AR element. However, when we want to draw, they need to use physical medium. For example, they need to use paintbrush to draw on the surface. And the available platforms are mobile, MetaQuest, and HoloLens. So the hand gesture interaction only available on MetaQuest and HoloLens. For mobile, there's no hand gesture interactions. And lastly, bare-handed 3D drawing in augmented reality, made by Department of Engineering, University of Cambridge, United Kingdom. Okay, this previous work satisfies all the elements which are drawing in AR space, hand gesture interaction, and also drawing guide. However, it only available on HoloLens, and it is not WebAR. So next, methodology. This is the project methodology. The project methodology is divided into 4 different phases. The first phases, analysis, satisfy the first objective of the project. The second phase and third phase satisfy the second objective of this project. And the last phase for satisfy the third objective of this project. So as you can see here in the design phase, second phase, the web augmented reality element and the hand gesture element are being separated and only integrated together in the phase 3. So in the WebAR subsection, I utilize the I utilize the markerless AR using ARJS location base, and then combine ARJS with A-frame to enable 3D drawing in AR, and then finally create AR 3D drawing guide mechanism. And in hand gesture, I utilize it to initialize MediaPipe landmark for hand gesture recognition for interactions. So now, how the ARJS location base being called or being used in this project? First, I request the geolocation access from user, and then obtain device geolocation, which is the latitude and longitude, then access the compass heading, the device orientation, and then uses navigator geolocation API to continuously track position and calculate users real-time position and orientation, and finally maintain live updates as user move. So this is only how to call the ARJS location base, not yet render it in 3D environment. So to see 3D environment and to see in 3D object being put in the real world, we need to integrate ARJS with the A-frame. So A-frame is built on top of Vue.js, and then incompatible with ARJS through components like async. And then to call it, we just need to call async ARJS, so start webcam to enable markerless AI using device camera, and then call the GPS camera inside the A camera to track user location via GPS, compass, and orientation sensors. It provides real-time geolocation awareness within the browsers. Now, the entire async is being wrapped, the entire AR environment is being wrapped under the async. So to enable like the virtual element enabled in the AR, we need to use the A entity GPS entity place to anchor the 3D object to the real world coordinate. So as I said earlier, entire scene become location aware and reacts to user movement in real space. So next, WebAR, 3D drawing guide mechanism, how it being implemented. First, we need to initialize touch-based 3D drawing. The reason why I make it touch-based first, because this is under the WebAR section, meaning that to test whether the digital element could be spawned in the AR environment or not. And then the shape vertices of the guide is being defined, and then initialize the checkpoint vertices, then initialize the law opacity visual guide shape in the A-frame, and then restrict drawing area. Previously, drawing is free, like user can draw anywhere, but now restrict drawing to only available near the shape edges, and then update the checkpoint status, and finally trigger success animation once all checkpoints are touched. Hand gesture interaction. So the um, hand gesture available in this project are the palm up gesture to open menu, fist or grip gesture to close menu, index finger movement to choose between tools and navigate UI, close peace sign movement to perform draw. So how to integrate all the elements into a single web application? There will be need to there is a need to run the media pipe and also the ArcGIS in a parallel. So how does the parallel structure being used, and why does it need to have parallel running? Because media pipe and post media pipe in ArcGIS, I'm sorry, both media pipe and ArcGIS uses the camera device. So in order not to make him in order to make them work together, there needs a layer structure to enable the technology to work together. So async is being put in front of on the top layer, so that anything that being drawn can be seen on top of everything. And then the input video is actually for media pipe to capture the user's hand, and then the output canvas is actually for the media pipe to draw the landmark and connector on user's hands. So next, the framework diagram. As you can see here, under the same web application, there are three different technologies, which are the ArcGIS, media pipe, and A-frame. So ArcGIS for the environment tracking. I'm sorry, for the location-based AR, and then media pipe for hand tracking and hand gesture interactions, and A-frame for the drawing guide, and also for the drawing mechanism, and also the 3D drawing guide mechanism. And then evaluation. So this is the evaluation flow for this project. User respondent first is being invited and then given briefing about the system, and then they are requested to fill in the consent form to allow me to use their data in this project. And then respondent was asked to fill the pre-evaluation questionnaire to check their current understanding about the WebAR element, the 3D drawing guide element, and also hand gesture element. And then I explained the tasks that respondent need to do, which was they need to complete all 9 guides in this project. And then I let the respondent choose whether they want to use the smartphone or tablet first. So once they complete everything, they still need to repeat the step. For example, if they choose smartphone at first, later on when they complete the all 9 guides, they need to do it in the tablet next. So they need to test it in 2 different devices. And then I provide the respondent with a link, and then let the respondent familiarize themselves with the framework first for 3 minutes. And then only then I ask them to complete all the tutorial mode, and I record their completion time and performance for the evaluation. And then respondent required to fill in the post evaluation questionnaire to check the overall satisfaction and so on about the system. And then this is the system requirement for the software. And library, I use A-Frame, ARJS, MediaPipe, and Visual Code, and these are the versions. And then for the hardware, I use Asus. My laptop is Asus, and it uses AMD Ryzen 7, RTX 3050, 64-bit operating system, and 16 gig, and Windows 11. So next, implementation. Functional requirement input. User can choose whether they want to join the free drawing mode or tutorial mode. User can draw freely using hand gesture interaction within the AR environment. User can select the tutorial mode, easy, medium, hard in the tutorial mode. Process. The web application should able to utilize user's camera and perform location-based tracking to display AR space within user's browser. The application should provide users ability to draw in 3D space. And the output, the web application should show 3D drawing guide on user's screen based on the chosen level. The web application should be able to show a message when user hand position is too far from the drawing guide. And finally, the web application should be able to show animated shape once user completed drawing in tutorial mode. Non-functional requirement, usability. The web application interface should be clear and easy to understand. Engagement. The web application should make the user feel engaged with the features used in the system. Satisfaction. The web application should give user satisfaction while drawing using hand gesture in WebAR. Finally, experience. The web application should increase user experience in drawing using AR. Next, the project design, use case diagram. So as you can see here, the user can view the start screen, can select the free mode or the tutorial mode. In the free mode, they can set the brush size, set the color, and clear the drawing. And in the tutorial mode, they can select the level and select the model. This is the system flow, as I mentioned earlier. So user can choose whether they want to use the free or draw mode or the tutorial mode. So in the tutorial mode, they are given the instruction, and then once they choose the level and the model will come out, and then the instruction will also come out, and then only when the user completed the drawing, the animation will come out. And once they finish the drawing, they can go back to the main menu to select other guides. So implementation of ARJS into A-Frame. So to integrate the ARJS into A-Frame, first need to copy the necessary libraries through content delivery network. So call the A-Frame and ARJS libraries, and then implement in the implement the ARJS inside the A-Frame A-Scene, and then call the GPS camera and rotation reader. And then we also need to find the device current location by using the JavaScript shown in the right side. Uses the navigator geolocation to get the current location of users through gyroscope and accelerometer. And the next, implementation of 3D drawing guide mechanism. We set up the visual guide. The visual guide is actually just to help the user to determine where is the shape and how it will look like. It is not the actual shape. The actual shape is actually defined in the 3 vector on the right side. And then the drawing area is being set up so that only when the hand is close to the drawing, close to the shape, only then the drawing will appear. And then set up the checkpoint, meaning that once all the checkpoint being hit, only then the drawing is complete. So next is success animation. And then finally, the drawing function. So in the drawing function, it calls first and check whether if the shape is already complete. If already complete, no drawing is the drawing will be disabled. If then it check if the hand is close to the to the shape. If it's not close with the shape, it will the text will show move closer to the shape edge to draw. And then only then, if like it is not yet complete and the hand is close to the shape, only then the drawing can appear. And then it will check the drawing whether it's already the drawing checkpoints, whether all checkpoints are already being hit or not. Once the checkpoint being hit, it will trigger the success. Next, implementation of hand gestures. So hand gesture, we first retrieve the hand model from MediaPipe, and then set up the canvas for the hand gestures. and then draw the connectors and landmarks. And then there we can set up whether we want to make it detect two hands or one hand. So in this project, I just want to use one hand. And then the minimum detection confidence means that how sensitive the detection is, and minimum tracking confidence meaning how sensitive when the user move their hand, how sensitive can it tracks the movement. And then map the hand position into the workspace, because media pipe, they only have originally they only track the X and Y position. So that's why I need to map it into the A scene to make it in 3D move 3D detection. So hand gesture recognition. So all the gestures are being initialized here. What determine peace sign, what determine open palm, what determine the closed palm, and so on. So here we can see the calculation is between the one landmark to another landmark. And then hand gesture interaction. So if the gesture detected, this kind of interaction happens. If peace sign, they will draw. If the close palm, it will close the menu. Open palm will open the menu, and so on. And this is the final application result for main menu. You can see we can choose the free mode or tutorial mode, and you can choose the level, you can choose the shape in easy level, you can choose the shape in the medium level, and you can choose the shape in hard level. And then this is the free mode UI. There is a button to go back to main menu, open instruction window, undo drawing, and then clear all drawing, change brush size, decrease brush size, and increase brush size. This is the final application result for tutorial easy. So the left side is the process, and right side is the output, the final output. So for example, drawing circle, now the circle complete, triangle complete, square complete. Then this is for the medium, and lastly this is for the hard level. Next, evaluation and results. So this is the experimental setup. So the evaluation actually outlined by the previous work, barehanded tree drawing in augmented reality paper made by University of Cambridge. So they use 18 participants for the evaluation, and so do I. So the evaluation was conducted within a day in a private setting with a total number of 80 participants. The setup consists of a user, smartphone, and a tablet. Users were allowed to move around as they wish as long as they don't leave the area. The important part of the setup was to ensure there was a stable internet connection within the environment throughout the testing, since this project required internet connection. So this is the execution of the experiment. So 18 participants were already tested the project, and the testing will happen in Friday, 13 June 2025 from 8:30 a.m. to 5:50 p.m. The total number of 18 participants participate in testing consisting of 13 females and 5 males. So as I said before, for the testing start, the user need to fill in the consent form and also being brief about the system, and they need to fill in the pre-evaluation and pre-evaluation form. Only then they can test the project, and after that they fill in the post-evaluation questionnaire. So during the testing, the first tester complains about like how heavy the tablet is. So to overcome this, I take off the tablet cover, and it seems like the tablet becomes more lighter and easier to draw. And then because the first respondent take too long to complete on a certain shape, I decided to limit the drawing only 5 minutes. So if the user cannot complete within 5 minutes, then they can move on to the next shape, but the completion time taken by them will be set by default 5 minutes. So this is the task completion time recorded by all the users. So as we can see here, there's not much difference between the smartphone and tablet users. And then the minimum time taken for the smartphone was done by the female 2 where she only took 7 minutes to complete all shapes. The longest time was taken by female 7, 32 minutes. Surprisingly, for tablet-based testing, the fastest and the slowest time completion time were both by male students. So the fastest time recorded by male 4, which only took 12 minutes, and then male 3 took 26 minutes to complete all the shapes. So after seeing the data, I can conclude that most respondents spend most of the time on the flower shape. Most of them said that the flower shape is hard to complete. This suggests that maybe it's because to the circular motion might require more effort and accuracy. That's why the shape take much more time. And then the most tree shape, and then through the testing, most of the common frustration shared by the respondents, they said there are times where the virtual shape is not generated correctly and shift from the original position. This is due to the ARJS location base because it doesn't anchor the virtual element on a specific uh, surface, but instead it anchors the element in the space, in the location. That's why sometimes it can move around. This is the summary of experiment, like I said earlier, already explained. And then this is the pre-evaluation questionnaires. So most of the all of the respondents interested in drawing, and they are interested in learning how to draw, and they have a lot of them already have their familiarity with the drawing software, and they also have well rate in their drawing skill. Then most of them, which is 83.3% of the user, does not have the prior experience with hand gesture interaction, and they doesn't know what is media pipe hand tracking. And then but 100% of them are aware of augmented reality and have used augmented reality technology before. Then these are the open-ended pre-evaluation questionnaires. Most of the user expect that they can draw object using hand gesture, able to draw easily and able to enjoy using it. And they expect that there will be a clear guiding and work smooth without lagging. And they expect to be able to draw using hand gesture and without canvas. And they also expect after using this project, using this system, they can learn more about AR and learn how to use hand gesture in drawing. And then these are the post-evaluation questionnaires. So I asked them to rate the difficulties on each level. And as you can see, the easy level are showing positive feedbacks. Most of them find it quite easy, or maybe there's some struggle, but most of them agree that it's easy. And the easiest, and next on the level on the medium level, for the bunny and sun shape, most of them agree it's quite okay. But for the flower, a lot of them have problem in completing it. And then for the heart level, most of them said it's fine to complete and it doesn't really have much difficulties. And then when I asked them to rate how engaging the drawing guide is, they said a lot of them agree that it's engaging, and a lot of them agree that the tree drawing is helpful, and a lot of them agree that it's comfortable to use the tree drawing. And from the respondent, most of the respondents agree that the easiest shape to complete was the house shape, and then followed by the circle shape. And then most of the respondents agree that the hardest shape to complete was the flower shape, and followed by the square shape. And then respondent agree that the detection of hand gesture is quite well, and then the comfort is quite well as well, and the engagement level is very engaging, and then the difficulty level to navigate through the UI using hand gesture wasn't bad, meaning that it's very easy for them to navigate through the UI using hand gestures. And then they agree that the hand gesture very satisfying to draw and interact, and they agree that the application is easy to access through web browser, and they feel it very responsive and stable, and they satisfied with the level of WebAR visuals. And then when we're asked about which preferred device they prefer. Most of them preferred to use smartphone compared to tablets. So why does they choose smartphone? Because it's easier to hold for a longer time compared to tablet, and it's lighter than tablet, and it's easier to handle compared to tablet. But people who choose tablet say that it's wider drawing area compared to smartphone, and it's easy to draw to hand, easy to detect hand due to wider screen. And then finally, the conclusion for this project. So the achievement, this project able to achieve all the three objectives, which is study and explore hand gesture interaction, to design and develop 3D drawing guide with web-based AR application, and develop AR 3D drawing guide application is interactive media that will increase users' driving experience using AR. So limitations are location-based AR environment occasionally causes instability in virtual shape positioning, resulting in misaligned or drifting shape, meaning that while drawing, the shape might go away, might float away from the original position. And then the system is dependent on individual body proportion. Users with shorter arms and thicker finger tended to face more difficulty when drawing compared to those with longer arm and slender fingers. And finally, location-based AR limited device with gyroscope and accelerometer, meaning that even though this application could be accessed through different devices, only devices that has hardware of gyroscope and accelerometer can use the AR fully. For example, if I open this project in laptop, it can run, but it doesn't have the AR element because laptop doesn't have gyroscope and accelerometer. And for the future work, it's good to improve the stability of visual anchor in AR space to reduce issues related to drifting and misalignment. This may be achieved by combining image marker or surface detection along with GPS, meaning that two AR in one application, perhaps. And then next, implement option to switch between front and rear camera based on user preference or drawing comfort. And finally, integrating custom shape creation, variety of brush size, and wider color palette to give user more freedom in drawing. So that is all from me. Thank you for watching.